with that dramatic video out of the way, let's go into how this program really works. So let's build the version that I will submit, this version. Here's a nice little start screen with an interactive buttons over here. So it's a physics-based game. We can use WASD keys or the arrow keys to move around and use the mouse to move the camera around as well. I was hoping to implement joysticks and show a video of at least running on an Android or an iPhone, but didn't have too much time left for that, so I don't have them implemented, as I'll show you the code later on. Here's some credits, just a nice note. The game was made by me, most of the art and assets were made by me, except for the lava textures, menacing Japanese text that we'll be using for the ball itself. Volcanic lava texture, which is the rock on which the terrain is being covered by, as well as music from Ben Sound. This font being the Mario font 256 by F. Suarez 913. Unity, copyrighted by Unity Technologies San Francisco, and you know, all the other legal shenanigans. So let's start that game. Take this as well. Kinda don't want these sounds to take over, so I'm just gonna mute this other program. If only Windows didn't change the whole music thing. That's the wrong one? No, that's the wrong one. Okay. So let's begin. So greeted to a somewhat dramatic setting with terrain being generated in the middle of all this lava, which is actually just one big lava texture. It's interesting to see, probably you can't see it from this angle, but this is actually the Smash Brothers logo that is printed on the field, which is actually what was my inspiration to do this game. So, oh yes, let's also have the chat server up as well to demonstrate that as well. And you know what? Let's connect the third client to us as well. Gonna have to mute that one. Where is it? There we go. Okay. So let's begin our chat server. So essentially, there are two different servers that will be running with this program. The chat server itself, which we could send and receive messages through sockets, and the actual Unity networking system between the players. I originally was going to have this chat server actually handle all the packets, especially network transform packets. Well, not network transform, but like the actual component of the Unity network. Not that, but like an actual packet that players would send between each other through sockets. I could not get that to work, and I'll explain in detail later on. So let's start this server. Make sure OBS is still recording. Is it? It's recording my voice. Hopefully this time. Okay, good. Okay. So let's start. So this server will listen for any connections. So let's actually connect 10.10.10.6, connect 10.10.10.6, connect 10.10.6. So now we're all connected to, I believe, the host. Let me make sure of that. hosting this. This will be a client, and this will be a client sent over there. Alright, good. So now let's type in a port. Type in a port. Let's type in a port. So let's have this one connect. But this one, we change our nick to A. Oops. A. This one to B. Nick. B. Let's connect. See, once people are connected to the chat server, which is an encouragement, their default names will change from A to B. I have the shift key to activate and deactivate the chat, which in hindsight is probably not the best button to have used after all, but oh well, at least it works. So there is someone in front of us right now. That's the wrong one. Yes. So let's collide with them. Hiya! Boing. And for each collision, there will be an added force that repels each of the spheres backwards. Unfortunately, I can't seem to solve this one small issue where it doesn't seem to be applicable to spheres that have a velocity of 0. Which means it's actually pretty. It's only effective when they're moving, which is kind of a down part on calculating. But it's encouraged that players would keep moving to knock off everyone off the field, as seen here. I have a damage of value of 173. The color of the damage is lerped from a bluish color to more of a reddish color to indicate how serious you will take your damage. Oh, that's pretty interesting. It reset my damage value. Yeah, but every time we fall into the death zone, we respawn. Oh no. Yes. And even the chat server can communicate with the players as well. Fools! You are not playing it right. And the chat's messages are also colored between the clients to indicate what type of message it is. So black, for instance, is a message that came from the server. White is a message that is sent between the clients. Orange indicating players connecting. Blue is kind of like a general purpose, like information, just to make sure things are working correctly. Purple is also registering your personal key, so that if people were to come in with two of the same nicknames, say like between these two clients, you'll be able to differentiate between them based on their unique key ID. And that pretty much does it for this demonstration. So let's go to the code. Oh yeah, that blue spinning sphere is an actual representation of the client manager. So, oh, and help. We can see who's connected to us as well. And since we never changed the nickname of this, they were assigned the automatic GUID. Alright, so that pretty much does it for this demonstration. So let's look into the code. Let's see what the time is. Okay, so the start screen has a lot of images for the canvas. All of these being buttons that when the mouse is over them, they all change into an assigned color, but I made sure to at least make some of them quite different. you can see that there's a pattern from this top row and bottom row to the next. So, because I kind of copy and pasted there. But still, I wanted to make the menu screen somewhat interactive, so that it kind of like pops up to say. And these three buttons over here, where did they go? I just saw you. Where did you go? I don't know why these three in the middle, but at least they're not being covered by the other buttons. So, start button. Yes, right here. Each of these buttons is connected to the main camera, which runs a script displaying telling it what function to run. So let's go to the main camera. Then Sound Summer is what's playing. And yes. Let's go to the menu buttons, which is a few short functions. When we start the game, we run this function to load the moving ball scene. The About message displays the About message, which is to essentially how to play. Display credit displays the credits, and if we were to click on any of the mouse buttons at any given time, then we just set the About and credit to false, as seen here. About and credits. Alright, so let's move into the game. Oh, and by the way, this client scene was just used for testing purposes, such as getting the client manager to work and etc. So let's go on to moving ball. Spawn token actually wanted to set up a system where not only can you bounce people by colliding into them off of the terrain, but it could also I also wanted to implement a system where you could collect these rotating spheres. No, I mean not rotating, rotating cubes as a point system, and every time you would die, you would lose half of your points. I didn't get too much time to finish properly implementing that, so I just disabled any traces of them for this project, because the main focus that my main focus of this project was to just focus on how does actually networking work, which pretty much 90% of my time was dedicated into making sure the chat server worked, which originally I wanted to be a server to handle the player movement and the chat messages, but that didn't work out, which I'll explain very soon. Directional light, we have our event system, our canvas, which we have our two joysticks, our scroll view, which is helps us scroll through the chat messages, and our input field, which we type in messages to send to the chat, and damage text and a name so that they're clamped to the player sphere and hover them at all times. And the floating damage and the damage label are kind of like actual game objects, so that they always float above the player. Damage text and player sphere. Do note that they have different tags, although this one is unused because mainly damage text has damage text and name has a name connect tag. So we have our lovely little terrain, whose material came from this stock fault lava, and the lava texture is the death plane itself, which if a player were to fall into it or fall below a certain height, they would respawn. So, yep, name label will stick around. Oh, and the main camera. It always looks at the instantiated player prefab, which is a local player. And the camera joystick, I believe, is the right one. We have a sensitive X and a sensitive Y to determine how fast the camera rotates around the player. And we want to make sure if the player is on a Windows or a Mac or any type of a desktop type environment, we want them to use the WSAD keys or the arrow keys. Else, if we expect them to be on an Android or an iPhone, then we would use the joysticks, which I didn't get too much into because I was kind of running low on time there. And you can see it take effect in here. We also want to have clamp our We also want to clamp our Y values between 0 and 89 degrees, so that the players don't necessarily move their camera over a direct 90-degree angle, which might confuse some people on how the camera was working. And we want to also prevent them from going below 0 degrees, so that they don't look underneath the map. Okay. Next we have ball move. Okay, so if we do start this on a local player, we want our main camera to be set to the transform of this game object, as well as clamp our damage and our name to the local player. So let me just add that comment for future reference. The main camera to follow the local player as well as clamp the name and damage to our player. But since this is a prefab, it's not going to be instantiated until we actually host or connect as a client. So while a prefab instantiates, or to be more precise, before it actually does instantiate, we want to make sure that these following values have some type of value and are not null in the process. These collision triggers and collision as a whole, I found it to be very interesting and kind of somewhat difficult to work with in a network-induced environment. How much time am I in? Okay, yeah. Because for some reason, even though I had two player spheres colliding, sometimes it doesn't register the collisions too well, especially if they're at a low velocity. So I did try to make sure to add the collision force whenever possible, if successful. Now here I tried to implement a command in a client RPC saying, hey, I bumped into a token and I wanted to despawn a token, but this is not really a this is not really relevant anymore. So you can kind of ignore this, I guess. Originally was intended for use with a token point system, but ended up being unused. So here we have the what allows our game to actually work. Since if we do collide with a ball, and sometimes the collision kind of doesn't work, so sometimes we'll just we'll just use random float variables as a vector 3 direction to send a ball flying somewhere whenever whenever we do make contact with the other player's sphere. And that's indicated by this try-catch statement, because this collision.contacts at array 0, that point, is supposed to measure the actual point of contact between the collision of two player spheres. But sometimes this contact list is empty for some reason. You would think that because two objects are colliding, there is a point of contact in which that collision was able to be called upon in the first place at all. But it's just weird to me that sometimes this is empty. Like, how do you have collision without any point of contact? That just defies what collision is in the first place. So I just have this set here as just going in the opposite way. And in case it were to be a value over 1, then we want to normalize it. And here we have a little bit of RNG, where if you critical strike someone else, whatever random percent that we got will be multiplied by 3. However, if we are also unlucky enough, then the damage that we deal to other people will be reduced to 1/3 of its original value. This force multiplier variable is actually what is technically being displayed over our player. Our force multiplier is equal to 1, but in the text over the player's spheres, we kind of quote-unquote lie and say it's actually 0, but it's actually 1 because we don't want to multiply a force by 0, else nothing would really happen. So then that's when we immediately change the text to be whatever force multiplier was plus whatever percentage we got. The lerp value also applies here, in which we want to lerp the color from a beginning color to an end color, from a blue to a red, as we take more damage. Here, if we enter a death play, then we just simply respawn. We respawn in 4 different zones, 1 for each side of the map, and that's how we just randomly spawn in. If we don't have, if it is our non-local player, then we return because we're not allowed to manipulate objects that are not ours to begin with. And here we just set our movement values in fixed update to calculate the physics. It was also meant to be used as a way to fix some of the collisions, but I wasn't able to make this work at all. A clamp name, we set it to our player sphere, and we just have this damage label just transform whenever the player moves. Same thing with clamp damage, except that the clamp damage is y+1 and the clamp name is y+2 over the player. We have move cam. It's got ball move, clamp. I'll come back to that. Joystick. So if we were to move the joystick around, it will send us data such that however much we moved it, we'll just give an input direction of a certain value like X or Z to be sent off to the ball move and the ball camera move scripts. Did I talk about ball moves? Yes, I did. Okay. So I'll save client for later. I talked about menu button, joystick, move cam. Oh, rotate. As seen on that cube over there, just simply rotate it. This was originally going to be used for the token scheme that I wanted to do, but kind of went unused. Oh, I mean, the whole system went unused, but not for the script as is being applied to that cube over there. And here was my attempt at creating spawns tokens, which would spawn on both client and server side, but it would only despawn on whenever the host actually collects a cube, and it wouldn't despawn on the client side, which was a problem that I couldn't figure out. So I just left this alone. I mean, I'm not gonna take it out because I'm at least just leaving it here just for like an insight of what I was originally trying to do, to at least show that I at least try to do some work on it. Okay. Let's go to client. So I have my client set up so that it essentially would work more so with the chat server. We store their IP, port key, name, and all this extra information, which I'll get to in a bit. So we don't want to destroy this client, and we want to well, originally I was going to attach and send the rotation and position of the player across the network, and I'll explain that in just a little bit more. Initialize key and an ID, and set these chat commands to false. And test connection values, this pretty much says that whatever the user typed in, it checks to make sure the IP and port is actually an IP or a port, or it can pass off as a legit IP or a port. And if we do, then we just connect to the server, and we have a thread to get all of our packets. This disconnect method might cause me some issues because I probably use them at the wrong places at the wrong times. But essentially just makes sure that the thread and the socket are non-existent. In the update function, if we're connected, then we just send our messages to other players. Else, then we just post them onto our scroll view. Or if we use our commands, then whatever input that we next get completes whatever command we're doing at the moment. Now the chat box is focused. If we want to shift, then we put it back into focus so we can keep on typing. And leaving chat box activate input field on is pretty useful, because if we want to send multiple messages, such as connect, and we had to send in a couple of lines, we don't want to necessarily have to keep clicking on the input over and over and over again. This remain clamp name was supposed to help in setting once the user would connect, the clamp name that hovers over the player serial would turn into their ID. But this method kind of went unused. This collision detection was an attempt at actually detecting collision between two players over my custom-made network, but that didn't work out too well. So essentially what I wanted to do in this fix update was we had a list of players where pack.data at 0 stands for the key itself. So I would call upon the list of the key and grab the position, rotation, velocity, and angular velocity. And we well, at least try to update them as regularly as I could from all the packets that I was getting from the server. And this right here, this is my original plan. Now it's kind of weird because I tried to restrict sending us packets through the network, because when I first tried this out, I kind of guessed that I was sending way too many packets over the network. But even though I tried restricting packets being sent, such as sending them only probably like 1 or 2 times per second, it still wouldn't work for me, because socket.receive always had some kind of issue, and I could never truly figure out what happened. And I didn't want to send packets at such a sluggish rate that it would just the network movement between players would just look choppy. So I kind of just gave up on that and focused on Unity's built-in networking for that. Oh, okay. So, kind of don't want to take up too much more time, so let's try to go with this. These help in posting messages to the chat server itself. Oh, not the chat server, but like actually posting it on the input view, or the scroll view, I'm sorry, right over here. These help to color in the various type of messages that we get. Here, get data, we read our bytes, deserialize our packet, and we handle it. If it's a registration packet, then we know we get a key, and we send a registration packet back to the server, which will probably be easier to explain if I show you. And my original plan was that this is kind of like an acknowledgement packet, that it would acknowledge that they got the key, as well as we would send them a packet of all the clans that are connected. And my plan was to send all the players that are connected and have the client instantiate every single one of the players through a socket back to which the registration packet was sent. And in the meantime, those who were connected were going to instantiate the newly registered player, so that the newly registered player who connected would instantiate all the other players, and all the players who were already connected would instantiate a new player. But that plan kind of fell through. But that was my original plan. Send just sends whatever message we got to be posted on the input view. Confirm registration essentially just helps to instantiate players, but again, this fell through. Heartbeat is to check if a socket is actually still there. Player transform, we would update whatever packet we got in main queue, because we cannot access any of the Unity's API in this thread. We have to do it in the main thread. So we just enqueue something and just send it to the thread, which is what I already do for chat messages anyway. These are offline commands to connect, set your nickname, and help. Online commands, which I kind of restrict the usage of nickname. This debugging just helps me debug in real time, so that's not really useful for now. And I spent a long time this on application quit, where we first want to close all available sockets and threads, else Unity would hang forever, which is something that I really want to avoid, especially with the threads. It was kind of an issue at first, me having to go to the task manager and close Unity every single time because a thread or a socket was still open. And it's a good thing that I finally fixed that after like almost a week or two of trying to solve it. Let's go to the server. So when we start, we initialize our list as well as wait update chat and the list of clients that we get. And once you type in the commands /start, let me start listening for the new connections. New message is essentially the same. Online commands is essentially the same, except that with connected, we I have a clever way to check who's still connected by sending a heartbeat message. And if this doesn't if this doesn't generate an exception, then we know that they're still connected. Update function helps us with the chat box. Sock thread helps listen for up to 10 connections, and we store each of the connections into our dictionary. Else, if we wanted to kill this thread, then we will set this keep listen left to false, and it will just peacefully leave the thread. We don't want to abort the thread because that's not good. And here's pretty much almost the same thing as in our client, where we receive some data. This data sends packets to all clients, such as a server message to everyone. Send transform data to all clients except self. That was originally supposed to be the use where I was supposed to send a transform packet, but I didn't want to update my own transform through the network. So I would have every other client every other client would have their version of me be updated as I move around in the network. But this kind of fell through since I was not able to get the player movement part working with the server. And handle data, where we just handle all the packets that we get. This helps us to post a message to the console with remembering that we still have to post messages through the Unity's main thread. And the same thing here, we want to make sure to close all of our sockets and threads. Careful. Getting client data is essentially like objects that we create just to store the client socket and the thread, so that we create a new thread per client that connects, so they could continuously send and receive data. Packet essentially just helps us serialize all of our values. So just my intended position and velocity, etc., into bytes. So that's pretty much the gist of this packet class. We want to turn into bytes, or if we get some type of bytes, we want to transform it back into a packet. And get IP helps us to host it on our private network in the first place. And if we can, then we just simply do localhost. Now for the player transformation manager, which is this awesome cube right here. This immensely helps in the fact that it helps to manage our player prefabs, my attention with the token cubes, and helps to link and network between all the clients to the hosting server. So it's technically two servers that we're working with. I do believe that I know I'm using TCP for the chat server, whereas I'm using whereas I believe UDP is being used with the network manager. And that's pretty much it. So thank you for watching. These are my prefabs, scenes, scripts. I do believe I went through everything. Small token, yeah. And that's pretty much it. So I believe that's it. I talked about my intention with the network transform, with the chat server, but that kind of fell through because either not enough packets or too many packets were being sent out. That's an issue with socket.receive not being able to receive network packets and just hanging on that line for some odd reason. Yeah, that's pretty much it. So thank you, and have a good night.